Hi and Assalamualaikum. My name is Zulizwan bin Zulfaidal from DKA 3C. My metric number is 11 DKA 19F1078.
Hi and Assalamualaikum. My name is Muhammad Fidaus bin Abdul Majid from Polytechnic Melaka at Plus DKA 3C. My metric number is 11 DKA 19 F1093.
Assalamualaikum. My name is Nurul Aida from DKA 3C. My metric number is 11 DKA 19F1054.
Assalamualaikum, my name is Nur Sharafana binti Muhammad Ashar from DK3C. My matrix number is 11 DKA 19F1006.
The definition of sewage treatment. Sewage treatment is the process of removing contaminants from municipal wastewater, containing mainly household sewage plus some industrial wastewater. Physical, chemical, and biological processes are used to remove contaminants and produce treated wastewater, or treated effluent, that is safe enough for release into the environment. A byproduct of sewage treatment is a semi-solid water or slurry called sewage sludge. The sludge have to undergo further treatment before being suitable for disposal or application to land. Sewage treatment may also be referred to as wastewater treatment. However, the latter is the broader term that can also refer to industrial wastewater. For most cities, the sewage system will also carry a proportion of industrial effluents to the sewage treatment plant that has usually received pre-treatment at the factories to reduce the pollutant load. If the sewage system is a combined sewer, then it will also carry urban runoff, stormwater, to the sewage treatment plant. Sewage water can travel towards treatment plants via piping and in a flow aided by gravity and pumps. The first part of the filtration of sewage typically includes a bar screen to filter solids and large objects that are then collected in dumpsters and disposed of in landfills. Fat and grease are also removed before the primary treatment of sewage. The term sewage treatment plant or sewage treatment works in some countries is nowadays often replaced with the term wastewater treatment plant or wastewater treatment station. Sewage can be treated close to where the sewage is created, which may be called a decentralized system or even an on-site system, in septic tanks, biofilter or aerobic treatment system. Alternatively, sewage can be collected and transported by a network of pipes and pump stations to a municipal treatment plant. This is called a centralized system. The origins of sewage. Sewage is generated by residential, institutional, commercial, and industrial establishments. It includes household waste liquid from toilet, baths, showers, kitchen, and sink draining into sewers. In many areas, sewage also includes liquid waste from industry and commerce. The separation and draining of household waste into grey water and black water is becoming more common in the developed world, with treated grey water being permitted for use for watering plants or recycled for flushing toilets. Essentially, a sewage treatment plant operates by circulating air to encourage the growth of bacteria to break down the sewage, the goal being to deliver much cleaner, more environmentally friendly effluent. It involves a similar process to a typical septic tank but has some key difference. Sewage treatment plants, depending on their size, can treat the waste of commercial properties or a number of domestic dwellings. Why are sewage treatment plants required? The first stop for anyone planning a new development should be getting connected to main sewers. They are typically the most cost-effective and reliable method of dealing with your wastewater. However, getting the main sewer connection isn't always possible. In some scenarios, the distance from the nearest sewer or the layout of the land can make it impossible to have your property serviced by a main sewer. That's where sewage treatment plants and other alternatives come in. The operation of a sewage treatment plant means that you can have one installed almost anywhere, and as long as you have an electric connection. Do sewage treatment plants still need emptying? The purpose of sewage treatment plants is to treat the wastewater as truly as practically possible, and even though such plants can often deal with more waste than a septic tank, They will still need emptying from time to time. Over time, sludge can also build up in the system, so it's important that treatment plants is regularly maintained at least once a year or as you are advised by the installer.
Preliminary and primary treatment is one of the wastewater treatment. The function of preliminary treatment is to remove material that cause damage plant equipment or would occupy treatment capacity without being treated. For primary treatment, the function is to remove settable and floatable solid may not be present in all treatment plants. For the advanced waste treatment is use physical, chemical and biological process to remove additional BOD, solid and nutrient. And the disinfection is to remove microorganism to eliminate or reduce the possibility of disease when the flow is discharged. For the process of primary treatment, it use bar screen, grief chamber and settling tank. And the sludge from settling tank go to sludge digester, and after that go to sludge drying bed. Preliminary treatment is the purpose of preliminary treatment is to protect plant equipment by removing this material that could cause clogs, jam or excessive wear to plant machinery. May include many different process like influent pumping, screening, shredding, grief removal, flow measurement, pre-aeration, chemical addition, and flow equalization. In primary sedimentation, wastewater enter a settling tank or basin. Velocity is reduced to approximately 1 feet per min. Solid that are heavier than water settle to the bottom, while solid that are lighter than water float to the top. Settled solid are removed as sludge and floating solid are removed as scum. Wastewater leave the sedimentation tank over an effluent where and on to the next step in treatment. Preliminary treatment will have little effect to pathogen and the liquid waste stream. Primary treatment, also called primary sedimentation, is a sanitation technology that removes suspended solid and floating organic material to reduce the suspended solid load for subsequent treatment process. The removal of pathogen during primary treatment is not high. Therefore, downstream treatment will require further pathogen removal technologies to meet discharge or reuse guideline. It is not expected that discrete pathogen and indicator organism are removed by settling during conventional primary treatment. However, they may be removed when attached to particle. In ordinary primary sedimentation system that are properly designed and operate, the reduction of all types of pathogen and fecal indicator can be expected to be between 0 and 1 log per 10 units. With chemically enhanced primary treatment and advanced primary treatment, also referred to as high rate clarification process.
Today I'm going to present about secondary treatment. Secondary treatment is a function to remove the soluble organic matter that escapes the primary treatment. It also removes more of the suspended solid. Removal is usually accomplished by biological processes in which microbes consume the organic impurities as food, converting them into carbon dioxide, water, and energy for their own growth and reproduction. The sewage treatment plants provide a suitable environment, even from steel and concrete, for this natural biological process. Removal of suitable organic matter at the treatment plants help to protect the dissolved oxygen balance of a receiving stream, river, or lake. There are three basic biological treatment methods. First is trickling filter, next the activated sludge process, and oxidation pond. So, what is the difference between primary and secondary wastewater treatment? The main difference is the way each respective treatment is processed. Primary treatment works on sedimentation, where solids separate from the true serval-driven tank. In contrast, secondary treatment uses aeration, biofiltration, and the introduction of waste throughout its process. A trickling filter is one of the biological treatment methods. A trickling filter is simply a tank filled with a deep bed of stone. Settled sewage is sprayed continuously over the top of the stone and trickles to the bottom, where it is collected to further treatment. As the wastewater trickles down, bacteria gather and multiply on the stone. The steady flow of sewage over this growth allows the microbes to absorb the dissolved organic, thus lowering the biochemical oxygen demand (BOD) of the sewage. Air circulation upward through the space among the stone provides sufficient oxygen for the metabolic processes. Settling tanks, called secondary clarifiers, follow the trickles filters. These clarifiers remove microbes that are washed off the rock by the flow of wastewater. Two or more trickling filters may be connected in series. The sewage can be circulated in order to increase treatment efficiencies. Next is activated sludge, the treatment technique in which wastewater and reused biological sludge full of living microorganisms are mixed and aerated. The organisms are grown and reproduced by using the organic material as food. Next, as they grow and mix with air, the individual organisms cling together, which is flocculate, and ready to settle in the secondary clarifiers. Other than that, the wastewater being treated flows continuously into an aeration tank where air is injected to mix with wastewater with the return activated sludge and to supply the oxygen needed by microbes to live and feed on the organic. What is aeration in wastewater treatment? Aeration brings water and air in close contact in order to remove dissolved gases, such as carbon dioxide, and oxidizes dissolved metal such as iron, hydrogen sulfide, and volatile organic chemical. Oxygen is added to water through aeration and can increase the palpability of water by removing a flat taste. Next is oxidation pond. Oxidation pond, also called lagoons or stabilization pond, are large, shallow ponds designed to treat wastewater through the introduction of sunlight, bacteria, and algae. Algae grow using energy from the sunlight and carbon dioxide and inorganic compound released by bacteria in water. During the process of photosynthesis, the algae release oxygen needed by aerobic bacteria. Algae remaining in the pond effluent can be removed by filtration or by a combination of chemical treatment and settling. Lastly, is about rotating biological contractor, in a short form of RBC. RBC is a fixed film biological treatment device. The basic biological processes similar to that occurring in the trickling filter. In this treatment system, a series of large plastic discs mounted on a horizontal shaft are partially submerged in primary effluent. As the shaft rotates, The discs are exposed alternately to air and wastewater, allowing a layer of bacteria to grow on the disc and to metabolize the organic in the wastewater.
Today I want to talk about disposal method. Okay, we have 5 types of sludge disposal method, which is the first one is incineration, lagoon and landfill, spray and irrigation, ocean and dumping, and the last one is composting. Incineration. Incineration is an extension of train process and converts solid into an inert ash that can be disposed of easily. The solids are dried and ignited. That means the solid was burned, and as they're burned, the organic matter is converted to carbon dioxide and water vapor, while the inorganic matter is left behind as ash or fixed solid. The ash is collected for use of disposal. The lagoon can receive undigested primary sludge, excess activated sludge, or digested sludge in either or interim process in the total sludge handling scheme. Normally, landfill are ultimate disposal location dried sludge, and this disposal method can be economically depending on the how distance from the wastewater treatment plant to the landfill. Spray irrigation is a modification of the system used in agriculture for irrigating crops. However, the objective is the disposal of liquid rather than providing moisture and nutrients to harvestable crops. After pre-treatment and grease removal, disease system spray wastewater through a sprinkler system onto land, and there is planted with special grasses. Ocean dumping. The concept of infinite ocean is it has given way to the reality that the ocean is a limited and valuable resource. Dumping waste in the ocean, estuaries or inland lakes is regulated by emission standard for abating pollution of the ocean. So the last one is composting. Composting is a few sewage work that compost sludge by the process of windrowing. The process generates heat and a rise in temperature in composting material causes pathogen destruction. For the essential of composting, it has 5, which is green and brown material, moisture, size of heap, aeration, and particle size and surface area. To improve treatment method, we need to have membrane bioreactor process, the ballasted floc reactor, and the integrated fixed film activated sludge process.
The summary and conclusion. The successful implementation of wastewater reuse option in the Water Resources Management Program requires careful planning, economics and financial analysis, and the effective design, operation, and management of wastewater reclamation, storage, and distribution facilities. Technology for wastewater reclamation and purification have developed to the point where it is technically feasible to produce water of almost any quality, and advances continue to be made. Current water reclamation strategies incorporate multiple measures to minimize the health and environmental risks associated with various reuse applications. A combination of source control, advanced treatment process flow schemes, and other engineering controls provide a sound basic for increased implementation of water reuse applications. The feasibility of producing reclaimed water of a specified quality to fulfill multiple water use objectives is now a reality owing to the progressive evolution of technologies and the understanding of health and environmental risks. However, the ultimate decision of harvest reclaimed wastewater is dependent on economic, regulatory, and public policy factors reflecting the demand and need for a dependable water supply, water pollution control facing the megacities. Through integrated water reuse planning, as discussed in this chapter, the use of reclaiming wastewater will provide sufficient flexibility to allow a water agency to satisfy short-term needs as well as to increase water supply reliability. With an increasing emphasis on the planning and implementation of wastewater reclamation and reuse facilities, accurate cost data are essential. Thus, cost information was presented, although there are significant variations in wastewater reclamation and reuse costs. Although drugs often underscore the need for wastewater reclamation and reuse, wastewater reuse is by no means a water resources management alternative for drought years only. It should be considered an integral and permanent part of water resources planning in the future.